Hello and greetings to everyone. We have the following questions in front of us. We have to answer these questions. The first question, question 1 says find the value or values of x for which 3 raised to the power 2x minus 5 times 3 raised to the power x plus 6 is equal to 0. I know most of you guys will be able to identify this equation as a quadratic equation. For those of you who cannot see that this is a quadratic equation, I'm going to proceed to express this equation in a form that can be easily seen by everyone. So we are going to start by saying let 3 raised to the power x to be equal to any variable of our choice. That means any letter of our choice, but the letter should be different from x, since this equation is in terms of x. So we can make use of the letter a. Next, if 3 raised to the power x is equal to a, then if we square both sides, the left hand side and the right hand side, this will give us 3 raised to the power x, all this squared, is equal to a squared. Then for us to simplify this, we are going to make use of this law, this law of indices, which states that a raised to the power m, all this raised to the power n, is simply equal to a raised to the power m times n, which is simply equal to amn. That means you multiply m by n. So we are going to apply it here. In this case, our a is 3, our m is x, and our n is 2. So this will simply give us 3 raised to the power. If you take x times 2 is equal to 2x. So here I'll write down 2x. So it gives us 3 raised to the power 2x is equal to a squared. Next, I'm going to write down this equation. 3 raised to the power 2x minus 5 times 3 raised to the power x plus 6 is equal to 0. Now, I'll proceed by replacing 3 raised to the power 2x with a squared and 3 raised to the power x with a. This will give us a squared minus 5a, replacing this with a, plus 6 is equal to 0. This equation, a squared minus 5a plus 6 equal to 0, is a quadratic. It's a quadratic equation. When we talk of a quadratic equation, we are simply referring to an equation of the form ax squared plus bx plus c equal to 0 with a not equal to 0 and a, b, c belonging to the set of real numbers, where x is a variable, x is an unknown. So this is a quadratic equation. In this case, our variable is a, and the highest power of the variable a is 2. This is a quadratic equation, and this quadratic equation can be solved by using the method of factorization. For us to solve this quadratic equation by making use of that method, we need to start by finding two numbers. We need two numbers such that their sum is equal to the coefficient of a, which is -5, and their product is equal to the constant term, the constant, which is 6. This is the constant here. It is independent of the variable a. In this case, those two numbers, the two numbers must be factors of 6. If we take -2 and -3, we know -2 plus -3 is equal to -5. Next, if we take -2 times -3 is equal to +6. We know if we are to multiply two negative numbers, the result, the sign of the result will simply be positive. Negative, if we take -2 plus -3, it is simply equal to, we know when we have positive, negative, the resulting sign is negative. This will give us -2 minus 3. -2 minus 3. Here, the negative sign is common, so we can factor out the negative sign. We write down 2 plus 3. So this will give us -5. Next, we are going to write down this equation. Where we have -5, we are going to replace -5 with -2 plus -3. This will give us a squared. I'll put the positive sign, I'll put the plus sign, plus -2 plus -3 times a plus 6 is equal to 0. This positive sign here, it changes nothing. Nothing has been changed, because we know if we take positive, if we have a positive, if we have positive, we take positive, negative, the resulting sign is negative. Next, this will give us a squared. Next, we have to expand this bracket, plus -2 times a gives us -2a. Then here we know positive, negative, the resulting sign will be negative. So this will give us a -3 times a, which is -3a plus 6 is equal to 0. Next, positive, negative here, I know negative will stay. So this will give us a squared minus 2a minus 3a plus 6 is equal to 0. Next, we are going to group the terms in pair and we factorize. So if we take the first pair here, we know that a squared is simply equal to a times a here. Then for the next two terms here, we have to find the let's find the HCF, highest common factor of 3 and 6. It will simply be equal to 3. So now we can easily proceed with the factorization. The first pair, we know a is common. If you factor out a in brackets, we know a times a will give us a squared. A times -2 will give us -2a. Next, for the next pair, we need to perform the factorization in such a way, in our brackets, we are going to have a minus 2. So if I write down, let me see, if I decide to factor out +3, if I factor out 3, in my bracket here, I will have -a plus 2. This will be equal to 0. I know 3 times -a will give us -3a. I know 3 plus, I know if I take 3 times 2, it gives us 6. But in this case, we need to factorize, we need to factor out something such that we are going to obtain a minus 2 in brackets here. So let's proceed. If we take now -a plus 2, this will be the same as, if I factor out -1, I'll be left with a minus 2. I know -1 times -2 will give us +2. So here I'll write this down, a minus 2. If I factor out -1, +3 here becomes -3. So here I'll have negative 3 times a minus 2 here equal to 0. Now I'm left with two terms, this and this. And a minus 2 is common. So I'll factor out a minus 2 times a minus 3. I know if I take a minus 2 times a, it gives me this. A minus 2 times negative 3, I will go back to this, is equal to 0. A minus 2 times a minus 3 equal to 0. It simply means either a minus 2 is equal to 0 or a minus 3 is equal to 0. We cannot make use of and because a cannot take two values at the same time. That's the reason why we are making use of the word or. Now here we need now to find a. This is a linear equation. For us to get a, we are simply going to transfer negative 2 to the right hand side, which becomes positive. This will give us a to be equal to 2 or a to be equal to, here we are simply going to transfer negative 3 to the right hand side, which gives us a 3. Next, we are not looking for a. We know a is simply equal to 3 raised to the power x. So we are going to replace a with 3 raised to the power x. So this will give us 3 raised to the power x is equal to 2 or 3 raised to the power x is equal to 3. If you take the first one, this is a star for 3 raised to the power x equal to 2. Here for this one, we need to find the value of x. 3 raised to the power x equal to 2 will simply imply that now if we take log to the base 10 on both sides, this will give us log 3 raised to the power x is equal to the log of 2. All these they are to the base 10. Remember, if you take the log of a, the number a, without writing the base, that means your base is 10. Next, we are going to apply the law of power here. The law of power states that if you take the log of a raised to the power n is simply equal to n log e. This will give us x log 3 is equal to the log of 2. Next, for us to get the value of x, we are going to divide all through by the constant log 3. This will give us x log 3 divided by log 3 is equal to the log of 2 divided by the log of 3. Log 3 will cancel log 3. They are constants. We are simply going to obtain our x as the log of 2 divided by the log of 3. And this result, the log of 2 or the log of 3, this result, we can still express it as such. We can write it as the log of 2 base 3. Here the base has simply been changed to a new base of 10. This is another way of expressing it. You can write this down as log 2 base 3. So let me just put it down. This will give us x to be equal to the log of 2 base 3. This is the first value for x. Now we need now to get the second value of x. I'll take 2 star for 3 raised to the power x equal to 3. 3 raised to the power x equal to 3 will simply imply that if we take log to the base 10 on both sides, log 3 raised to the power x base 10 is equal to log 3. Next, if we apply the law of power, this law, we are simply going to obtain x log 3 is equal to the log of 3. Next, we are going to divide all through by log 3. This is a constant, so that we can get x, because we want x to be alone on one side. This will give us x log 3 divided by log 3 is equal to log 3 divided by log 3. Log 3 will cancel log 3. This log 3 will cancel this log 3. The right hand side, this will simply be equal to 1. Log 3 divided by log 3 gives us 1. This will give us x to be equal to 1. So this is the second value for x. Now we are going to conclude. Therefore, you see that we have two values. Therefore, now x is equal to log 2 base 3 or x is equal to 1. These are the values of x. So if we go to that our equation, we replace x with log 2 base 1 base 3, or we replace x with the value 1. We perform all the necessary simplifications, we are going to obtain 0. Let's verify and see. The equation is 3 raised to the power 2x minus 5 times 3 raised to the power x plus 6 is equal to 0. Let's take the left side, then we replace x with 1. This will give us, let me write this down, for x equal to 1. 3 raised to the power 2 times 1 minus 5 times 3 raised to the power 1 plus 6 will simply be equal to, this will give us 3 raised to the power 2 times 1 is 2 minus 5. 3 raised to the power 1 is 3 plus 6. This will simply be equal to 3 squared. 3 squared is simply 3 times 3, which is 9. This will give us 9 minus 5 times 3 gives us 15 plus 6. This will simply be equal to 9 minus 15. It gives us negative 6. Negative 6 plus 6 gives us 0, which is true. The same thing, if you replace x with log 2 base 3, you'll still obtain 0. Now we can proceed now to the next question, question 2, which says solve the equation. You have to solve this equation. The root of 7 plus 4 root 3 is equal to a plus root b. We have to solve it for a and b, and we have been told that a, b, they belong to the set of integers. When we talk of the set of integers, we are simply referring to the set of positive whole numbers and their negative counterparts, including 0. This is a set of integers. Z is equal to, start with 3 dots. These 3 dots, they simply indicate that the set is infinite to the left hand side. It goes to negative infinity. You can start from negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and so on. The right hand side, the set is infinite. It simply means a and b, they are whole numbers. They are positive or negative whole numbers. Next, for us to answer this question, we are going to start by squaring both sides of the equation so that we can eliminate the square root sign. If we square both sides, the root of 7 plus 4 root 3, all this squared, is equal to a plus root b, all this squared. This and this will go, they will cancel. This will give us a 7 plus 4 root 3 is equal to, in this case, we cannot say this square will cancel the square root sign on b. What of e? E is out of the square root sign, so it is not true. In this case, we are simply going to expand this bracket. I will give a shorter technique, a shorter method of doing it. Instead of us writing something like this, then we start expanding the brackets. A times a equal to a squared plus a times root b, which is a root b, plus root b times a gives us a root b. Here we respect the alphabetical order. Instead of writing root b a, we write a root b, then plus root b times root b, which gives us root b, all this squared. This and this will cancel. Then you see this will give us a squared plus a root b plus a root b. Is the same as adding 1 apple plus 1 apple, which gives us 2 apples plus b. So this will give us a squared plus 2a root b plus b. A shorter way of doing it is simply, since we have two terms, we are going to take a, raise it to the power 2, plus we take the power here, which is 2, take 2 times a, the first term, times the second term, which is root b. If the sign here was negative, then we are going to have a negative sign here for the second term. Since the sign is positive, that's why we have a positive sign here. Then plus, for the last term, it is always positive, plus root b, you raise root b to the power 2. So when the power is 2, this is the shorter way of doing it. This will give us 7 plus 4 root 3 is equal to a squared plus 2a root b plus this and this will cancel, plus b. This will give us 7 plus 4 root 3 is equal to a squared plus b. I'll bring these two together because they are rational numbers. You will see they don't have the square root signs on them. Plus 2a root b. This one has a square root sign over b. Next step, we are going to equate the rational part of the left hand side to the rational part of the right hand side. We are going to equate the irrational part of the left hand side to the irrational part of the right hand side. Let's equate them. Equate them. Equate them. This will simply give us, write this down, that is, equate both sides, that is, this will give us a squared plus b, which is the rational part of the right hand side. It should be equal to the rational part of the left hand side, which is 7. We have here 7. I'll call this one equation 1. Next, the irrational part of the right hand side, we are going to equate it to the irrational part of the left hand side. 2a root b is equal to, is the irrational part of the left hand side, 4 root 3. We have these two equations. This one I'll call equation 2. If we take equation 2, equation 2 can be further simplified. If we divide all through by the coefficient of a root b, which is 2, let's divide equation 2 all through by 2 divided by 2 is equal to 4 root 3 divided by 2. So if we divide by 2, 2 will cancel this. We'll be left with a root b is equal to 2 will go into 4 2 times root 3. This will give us 2 root 3. Next, we are going to equate the coefficients. Here, we have a root b, the left hand side. The right hand side, we have 2 root 3. A is out of the square root sign. So a must be equal to 2, which is also out of the square root sign. In this case, this will give us a, then our a will be equal to 2, and our b will be equal to, here, you see root b is under the square root sign. Here, 3 is under the square root sign, so b must be equal to 3. Next, we are going to use now equation 1 to verify the values of a and b. Let's make use of equation 1. Equation 1 says a squared plus b is equal to 7. we are going to put the values of a and b here. Then we simplify. We know a is equal to 2, so this will give us 2 squared plus b, which is equal to 3. This will simply give us 2 squared is simply 2 times 2, which is 4 plus 3. 4 plus 3 gives us 7. So it simply proves that the values of a and b are correct. Now we are going to conclude. Therefore, a is equal to 2 and b is equal to 3. These are the values. We underline them. And you can see the values for a and b, 2 and 3, they belong to the set of integers. They are positive whole numbers. 2, 3 belong to the set of integers. If after solving we had, for example, a fraction as such, let's assume we had a to be equal to a half and b equal to, let's say, 6/5. Then in this case, you know your answer is already wrong, because these two values, they don't belong to the set of integers. If you had a case where a is equal to 2, then we had b as a fraction, then you know it is wrong, because from the question it has been precise that the two values, they belong to the set of integers. So you take note of that, and we are done with the solutions of the questions.